All right, now we're going to move on to adding and subtracting radical expressions. Adding and subtracting means you have to have like terms. We're familiar with that idea. What makes something a like term with radicals is if they're taking the same root. So a square root and a cube root are not like terms. A square root and a square root might be like terms. We're getting closer if the number underneath, if the radicand is the same as well. So I'm just going to rewrite this, arrange it with our roots together. So we have a square root of 20. I'm going to bring over the minus square root of 5, then minus cube root of 16, plus the cube root of 250. Okay, so right now our square roots are not like terms, but can we reduce the square root of 20? Any perfect squares fit in? 4 fits in 2 times. Nope, 5 times. So this turns into 2 root 5. I'm going to carry down the minus root 5. So those are now like terms. We'll be able to combine those in a minute. Cube root of 16. Now we're going to try to break this down with our perfect cube numbers. So remember, 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125. I think that's as high as we need to go on this one. So do any of our perfect cubes fit into 16? 8 fits in, so we're going to break it down with the cube root of 8 times the cube root of 2, because 8 times 2 is 16. I'm actually going to write this a little bit lower. All right, so minus the cube root of 8 is 2. Carry down our cube root of 2. Can we break down 250? Do any perfect squares fit into 250? This is why I went all the way up to 5 to the third power, because 125 fits in 3 times. So we can break that down with the cube root of 125 times the cube root of, did I say 3 times or 2 times? It fits in twice. All right, the cube root of 125 is 5. We can get that right from our list. So plus 5 cube roots of 2. All right, so now do we have any like terms? These are like terms. You have 2 root 5 minus 1 root 5. That leaves you with 1 root 5. Your root 5 do not change. Here we have a negative 2 root 2 plus a 5 root 2. So all you're doing is you're adding the numbers out front. Negative 2 plus 5 is a positive 3. And the cube root of 2 stays the same. So there's our final answer on that one. Oh, good. We get to take a look at a nice little word problem. The design shows the boards needed for bracing the back of some set scenery. Will 75 feet of wood be enough for all the bracings? So I'm going to redraw this just so we can clearly see what our picture is. We have 4 by 4, and then we've got diagonal boards, which we don't know how long those are. Right next to, oops, I'm not butted into my picture. This is 7 by 7, and we don't know what our diagonals are. So let's find the diagonals of each square. In case they didn't tell us, if it wasn't clear, it's a square, those are squared. Those are squares. So the small square diagonal, we can use Pythagorean theorem. You do have right triangles. So 4 squared plus 4 squared equals, I'm just going to call that one a squared. 4 squared is 16 plus 16 is 32 equals a squared. Square root both sides, so a equals the square root of 32. But can we reduce it? Let's see, 16 fits in twice. So a is equal to 4 root 2. So if I look at this picture, each diagonal is a 4 root 2. And the other diagonal is a 4 root 2. So again, we're trying to figure out if we have enough wood. We've got 75 feet. We're going to end up adding all these pieces of wood together. We also need the large square diagonal. We can find the hypotenuse of a right triangle over there. 7 squared plus 7 squared equals our diagonal. I'm just going to call it b squared. 49 plus 49 is 98 equals b squared. Square root both sides. So b is equal to the square root of 98. Do any perfect squares fit into 98? 49 fits in twice, so that gives us 7 root 2. So we had to do a little bit of prep work on this one. So now, to find the total wood needed, let's add up all of our sides. So for the small square, we've got 4, 4, 4. This fourth side is actually butting right next up to the other square, so this will be included with this board, which is 7 feet long. So we have 4 times 4, or 4, 4, 4. I'm just going to say 3 times 4, plus we've got a 4 root 2 plus another 4 root 2. So we have 2 of those 4 root 2s. So that's all the wood we need for the small square. We're going to add on to it. In the big square, you've got 7, 7, 7, and 7. So we have 4 sides with a 7. We also have our diagonals, a 7 root 2 and another 7 root 2. So we have 2 of those. And now we just simplify this. 3 times 4 is 12. 2 times a 4 root 2, we just multiply the 2 and 4 together to get 8 root 2. Plus 4 times 7 is 28. Plus 2 times 7 is 14 root 2. We've got some like terms. 12 plus 28 is 40. These are like terms because they both have a square root of 2. 8 plus 14 is 22 root 2. Now, if we were to type that into our calculator, because we want to know if 75 feet is long enough, we get about a 71.1. So we need 71.1 feet of wood, and we have 75 feet. So yes, 75 feet is enough.